So we've covered artificial intelligence and machine learning. We're going to need to think about data next. What data is and what we kind of look at for data, and we're going to talk about how we might use that in a machine learning process. So data. Data is an important concept, but we think about data, we use data, we interact with data, we generate data, but we all kind of know what data is. But when you ask someone to define data, what is data? I think people suddenly have a hard time kind of relaying a precise definition of what data is. We think of data as facts, statistics, observations, text, signals, readouts, sometimes images, sometimes other types of data. All of those are going to be data in some way. And we think about how all of this is collected, how all of this is stored. There's a whole lot of considerations that come along when we start working with data. So we're used to thinking about data visualization, and we're used to thinking about the text data, databases, numeric data, but data is actually quite a bit more complicated than that. So one of the things that we're going to have to think about when we start looking into artificial intelligence and machine learning is big data. What is big data? Well, in computer science, if you're a computer science student, information science student, even if you're just sort of a hobbyist, you've probably thought a lot about data. Data in text files, data that I'm processing, data, SQL queries, things like this. That's all in the realm of data. But when we think about big data, that's kind of a newer concept. I'm older than the concept of big data is a good way to think about this. Big data came about probably in the last 25 years. And part of that is because we didn't really have a way to think about big data before that. In the early 90s, you were just worried about what you could store on the tiny capacity hard drives that you had. Storing a ton of data wasn't really something we thought about. Back in the 90s, the amount of data that you could put on your system was probably about as much as you could wrap your head around. But I think that when we started getting into the internet, now you have many computers all connected together, hosting websites, hosting data, hosting all sorts of things. So if you think about Google, Google had to organize all of this information, make it searchable. Facebook has all of this social media data where people are updating posts and images and videos and likes and comments and all of this very quickly, very rapidly. And then Amazon, which has all of this product data that is coming from all of these different sources, and all of this pricing data and all of this data necessary to kind of look at what people are buying and how to make recommendations. So this idea of data is pretty, the big data is a pretty new concept, because we didn't have to think about large amounts of data before. So how big is big data? Well, I don't know that there's a line for this. Gigabytes could be big data. Sometimes gigabytes of data could be kind of too difficult to just kind of look at and understand. Terabytes, which are 1,000, a terabyte's 1,000 gigabytes, or a petabyte is 1,000 terabytes, or an exabyte is 1,000 petabytes. Maybe the line is anywhere here. I think it's very difficult to say what big data is. We kind of know big data when it's big enough. When you can't use basic techniques of just simple algorithms, simple databases, we kind of start thinking about big data. And sometimes that actually has more to do with the shape or the type of data that you have, more than the amount of it. So this comes about as a combination of hardware and software. If you go back into the 90s, or go back even into the early 2000s, storage was expensive. It was not so easy to take a bunch of data and store it somewhere. You had to be kind of economical about what you chose to store. But once storage got a lot cheaper, and storage just gets cheaper and cheaper, you were suddenly able to store more and more things. Plus, software kind of catches up to introduce new ways to analyze data and understand your data. So this is one of the things that drives big data is, you have hardware that is affordable, that's capable, and then you have software that is, more capable of analyzing new problems. And when you combine these two, well, now suddenly we can do all sorts of things. Like there's this process called datafication, which has arisen in the last several years, or last probably late 2000s, early 2010s, where you can just take every single thing that anybody interacts with on your site and you can store it. So like Netflix can use all of the interaction that a user might have with everything that they do in order to create new recommendations. And I think this datafication process isn't possible if it costs you $10 to store a megabyte. But if you can buy a 4 terabyte hard drive for $90, suddenly this becomes much more affordable. You can store a lot of things for a long time. You don't have to worry about what that's going to cost you. So Big data means you might collect more. It means you have to store more, but it also means you have new analysis techniques. And this is where machine learning and AI come in. Looking back, 15 years ago, 20 years ago, big data was all about how do we take, gigabytes, terabytes of data and make some meaningful conclusion from what it's doing. How do we make a prediction? How do we understand the trends? How do we use it effectively? But machine learning and artificial intelligence do give us some ability to take all of that data and not only make sense of it, but also apply it to new predictions, new encounters that we might have with needing to use that data in a way that we can leverage conclusions as opposed to just visualizing.